Diana Sosa, your favorite astronaut. And today I am going to use the Seestar for star clusters. And star clusters are one of my favorite. It has an aperture of 50 millimeters, a focal ratio of f5, and the focal length is 250 millimeters, which is very good for such a tiny telescope. It's an all-in-one telescope. It's fascinating, very precise telescope. And it has a pixel size of 2.9 micrometers or 2 with a resolution of 1020 by 1080, which put us in equivalent to 2.1 megapixel. It's very important to consider the sky levels, and in my case, I am in the Smoky Mountains in East Tennessee, right here next to Dollywood. Lots of attractions, lots of billboards. The water level is around 5 to 6. I think it's more 6 because of all the lights that I have around. I'm just writing 2158 NGC in the Sky Atlas and then go to. And the telescope is looking for the target. Once the two squares get parallel one on each other, it means that it found it. I started the imaging session on 20 seconds per frame shutter speed, but I started getting messages about star trails, so I decided to lower to 10 seconds. The seeing conditions were not the best, so better to go with 10 seconds this time. And let me just go back here to the advanced settings, and I am going to lower it to 10 seconds because I want to keep as many frames as I can. Save them, and I think that's about it. But look at that, it's looking good. This one, Star Trails, failed. So let's see, right now it's at 7 minutes and it's at 10 seconds exposure time. Yeah, but that looks good to me. This is exciting. Once again, the seeing conditions are below average, especially on the transparency. But this is good. This is exciting. 12 minutes. Oh, just one frame has been rejected, but it has been a while that hasn't been anything rejected. 31 minutes. Huh. This is looking good. Yes, absolutely. Take a look here. I've been walking all over outside, checking on the telescopes. But this star cluster is going to look very pretty on the stack image. It's also when I edit it. Yes. And then we are going to compare it with the Seestar, the stack image that came straight from the telescope without doing any enhancement, just the AI enhancement that the telescope does. Then I have also the stack image just on the fit format for me to be able to edit. And then I am also going to stack all the images myself. Okay, so I was able to get 242 images, and these ones are the ones here on the fit format. At 10 seconds, unfortunately, it is just 40 minutes and 20 seconds integration time. I normally do about an hour and a half at least on the star clusters, and that is using even 30 seconds exposure time with my big telescopes. The weather was not cooperating. The seeing conditions are not good. I am going to change here a little bit, enable the drizzle configuration, and this should help a lot. And I am going to increase here a scale to drop shrink to about 0.80. And this way I can bump it up a little bit, the resolution on these images. Let's see what happens. So the image is done, integration, and here's the rejection low. Look at that, all of that on the star alignment. And here is my image. And of course it's going to be green. And here it is. Okay, we're going to work on this. Let me just go ahead and bring it here. Okay, so there you go. Wow, the stacked image looks really good too. On the FITS format, it's a little better because I am sure that it has some AI enhancement. This trails here, the stars. Let's take a look at the stars so we can compare. Okay, I think they're very similar, the stars. Okay, so now I am going to start working on all of this. The outer linear fit balance those levels on the different channels. And I have to cut this part here. So I'm kind of like going to crop somewhere right here, which is a little sad that I'm going to lose part of it. Let me see if I can kill a little bit of that green. Dynamic extraction completed. Let's see the extraction here. Okay. Yeah, that's a lot. Blur exterminator. Yep, I think this one looks better. So I'll just go ahead and stretch the image. Oh, that looks good. Let's see from what I can see. So now the image is stretched and it needs sharpening too. The generalized hyperbolic stretch in the linear mode here. Okay, let me just do some clipping here. Oh, and now I'm going to need a star mask. Okay, so now this is the stack image on the FITS format from the telescope, and I'm just going to kind of like do some of the processes the same way. This is the extracted from the image. This one is looking different now. Let's see, noise exterminator. And finally, let me stretch this image. And this is the stacked image and enhanced in the telescope. So this has no other processing or anything. And I'm just going to crop. Start with that. And a little bit of sharpening too. Let me just leave it like that and see how this one looks. This is actually pretty good too. So now I am going to see all three images. So this one is the one that I enhanced, but it comes straight from the telescope. It had all the AI enhancement from the telescope. This is the Seestar stacked image that I enhanced, and I did all of the processing. And my image that I did entirely everything from stacking the image, all the calibration, and everything. Which one you like better? 1, 2, 3. Leave a comment. Let me know. 1, 2, or 3. I'm not doing too many settings, advanced features or anything. I know how to do it, but I want to show how simple and effective this telescope is. And don't forget, I also have a channel in Spanish, and the name is Tu Astro-Nerd Favorita. So if you speak Spanish and prefer to watch all of this in Spanish, the link is in the description. Thank you so much for watching.